This is example 8-7, flow in a river. So we have a river that is flowing at 3 meters per second. And we're building a model, and in that model, the river is going to, the water is going to be moving at 0.75 meters per second. And so now then the question is, how deep is the water in our model going to be compared to the 6 meters that the actual river is at? Now, if we think about flow in a river, the main forces are going to be inertia forces and gravitational forces. So we'll talk about the Froude number. So we can say Froude number, and that would be Fr is equal to the velocity divided by the square root of g times the length. Now in our case, the length that we're interested in is going to be the depth, so let's write that as g times d. Now for these models to be consistent, right, we need to have the Froude number stay the same between the model and the actual river. So we can say Froude of the model is equal to Froude of the prototype, I guess, or reality. So that would then be the velocity in the model divided by the square root of the gravitational constant stays the same. We're not going to build models with different gravitational constants. But the depth in the model equal to the velocity of our actual river divided by g times the depth of the actual river. And that means we can start to solve for what we're looking for. We're looking for the depth. So let's square everything up first to make it a little easier. Squared over g times dm is equal to vp squared over gdp. That's kind of funny. That of course means we can flip that around. That means, the g's cancel out. We have on both sides, so that would be dm over vm squared is equal to dp over vp squared. We can solve that for our depth in the model. So dm is then equal to vm squared over vp, or multiply that, and then times the actual depth. And that means, well, I guess we can pull those together, right? So we can say that'd be Vm over Vp squared times dP. It's nice because then we have a smaller number to square up. So that means if we look into our problem statement, the model velocity is 0.75 meters per second. The actual river is flowing at 3 meters per second, and the actual depth is 6 meters. So that leaves us with 0.375 meters would be the depth that the flow depth that our model will have in order for the flow to be equivalent.